Alright, so this video is going to be part 10 of our convergence and divergence problems with series. Okay, this is the last video, last problem. Okay, I just wanted to go through this quick because it's got an arctan in it, and not everybody knows how to deal with arctan. So we have the sum from n equals 1 to infinity of -1 to the n times arctan of n over n squared. We want to see if this series is absolutely convergent, conditionally convergent, or divergent. And I mean, you kind of have to, and I should have even put this, I might even go do it now, put it in the like what you need to know for Calc 2 video. Like arctan it pops up so much, and what you need to know about the Arctan graph, okay, y equals arctan of x, is that it asymptotes, it looks like this, and it's got horizontal asymptotes at pi over 2 and negative pi over 2, okay, and that's crucial. Now for series, I mean, this is n equals 1 to infinity, we're only going to deal with the positive part of this, okay, so that's all we really care about, and of course, this is just going to be, well, dotted, because that's a sequence, right? So first, we need to figure out how we are going to see if this is convergent or divergent, okay, that's the first step, because we're not going to be able to do any like kind of ratio or root with this, okay? So we're going to have to, we'll start out with that test for divergence, might as well, okay? That's the first step, that's the D, okay? Now, the limit, as n approaches infinity, of -1 to the n times arctan n over n squared, well, this -1 to the n here, that goes away, okay? We don't need to worry about that. Arctan of n, well, arctan of n, as n approaches infinity, that's going to become pi over 2. Okay? So this is just going to be pi over 2. Now, we have an n squared on the bottom, and that's what's going to become infinitely large, and that's why this limit will equal 0. So the test for divergence tells us nada. Integral test, not going to work here. Neither will comparison or limit comparison, and ratio and root, I already said, won't work. You're down with alternating series, you don't really got much of a choice here. Now, for alternating series, we need to see if this is decreasing, and we also need to remove what's making it alternating. Okay, so we need to see if arctan of n over n squared is going to be decreasing. So we take the next term in the series, that being arctan of n plus 1 over n plus 1 quantity squared. Now, arctan of n over arctan, and compare that to arctan of n plus 1, I mean, you're not really changing much here. Okay, you're not going to be changing much, and especially, I mean, as you get later on into this arctan of x graph, okay, you're not really changing much. Okay, however, this n squared and this n plus 1 quantity squared, okay, that's definitely going to be the bigger difference. Okay, so what you're going to have here is, since this denominator is definitely bigger and, well, the numerators aren't really differing by too much, okay, what you're going to have here is that this whole fraction becomes smaller than this one. Alright, so this is decreasing, so we can put a little green check mark here. And now we need to take the limit, as n approaches infinity, of arctan of n over n squared. Okay, now this is basically the same exact thing as we did up here. Okay, same reasoning applies. This is going to equal 0. Okay, and that works here. So this is going to be convergent by the alternating series test. Since it is converging here, now we're going to need to figure out whether this is conditionally convergent or whether it is absolutely convergent. So let's do that over here. We have the new series, the sum from n equals 1 to infinity of the absolute value of -1 to the n times arctan of n over n squared. Okay, and, well, that just removes the -1 to the n, so let's get that out of there. The sum from n equals 1 to infinity of arctan of n over n squared. And now we need to figure out whether this is going to converge or diverge, so we can write out our checklist here, DICLAR. Okay, test for divergence. Of course, we know that that is going to be 0. That's not going to help us at all here. Integral test, yeah, not happening. We could do a comparison though. Maybe we could do a comparison. Let's try to compare this to something. Well, arctan of n over n squared, definitely could probably compare that to the p series 1 over n squared. But arctan of n, that's going to be greater than, well, it's going to end up being greater than 1 here. So, well, that means that you're just going to have that arctan of n is over n squared is going to be greater than 1 over n squared. And that's a problem because 1 over n squared, we know that that series is going to converge. So this doesn't tell us anything. What we have to do now, of course, is use the limit comparison test. Okay, because this comparison test won't tell us anything. Okay. Now, to do the limit comparison test, all you have to do is take the limit as n approaches infinity of a sub n over b sub n. A sub n is this piece right here, and b sub n is this piece right here. Okay? Put them over each other, so you have arctan of n over n squared, and that's going to be over 1 over n squared. Okay? Well, these n squareds, of course, they're going to go away, and you're left with the limit as n approaches infinity of arctan n. Okay? That arctan graph, that really matters here. Okay? The limit as n approaches infinity of arctan of n, that is equal to pi over 2. Okay? That's equal to pi over 2. Now, that is a finite number, okay? And that is greater than 0. What that tells you is that either both these series are going to converge or both of them are going to diverge. Since we know that this series converges, this series is going to converge as well, okay? So this is convergent by the limit comparison test, okay? And that means that this series right here is absolutely convergent. So we're actually finally done now. We've done all, and hopefully you've stuck through all 10 videos. Now you should be a lot more comfortable with trying to see if a series is convergent or divergent, or maybe conditionally convergent, absolutely convergent, all that stuff. I hope this all helped. So yeah, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.